Here we have a wonderful material for geometry, which actually serves two purposes. The first is to help students to discover the formula for the area of a circle. It's similar to other activities that we do with the students when they arrange the pieces into a rectangle or a rectangle-like shape. This rearranging into a rectangle is a key concept when it comes to discovering area formulas. Now, when students do this with a circle, we can't quite get a rectangle. Instead, we have something that kind of resembles a rectangle, or even a parallelogram. Down here, we have the frame for the pieces, and this is one of the advantages of this material, especially for students who may already know the area formula, but have either forgotten it or don't really understand where it comes from. The Inset allows for a different kind of visual and impressionistic work, and can be done a little more quickly with our older students. When we arrange these pieces into the frame, either with the first circle, which has been cut up into eighths, or the second, which is in 16 pieces, we can see that half of the curvy part, or the circumference, is along the bottom in each. This means the base is half the circumference, which is half of 2 pi r, or just pi r. The height is equal to the radius of the circle, which is r, and multiplying base times height gives us pi r squared. So that's very cool that we can see this. But a second very important principle should be emphasized with our adolescents in a way that's a bit more formal, and that's the idea of infinities. The advantage of this inset is that just looking at the frames into which the pieces will be placed tells us something. Here in the first one, we see that the bottom is somewhat rounded, but in the second one, it's less so. Why is this? What would happen if we kept going by cutting this circle into 100 pieces or 1,000,000? We can imagine clearly that these pieces would be so small they would eventually look like straight lines. And we could get this bottom to be as straight as we would want by cutting up the circle more and more. This is the idea of the limit, which is the foundation of our work in calculus. And we can formalize that a little bit here by saying that we can get arbitrarily close to a straight line at the bottom by cutting the circle into a sufficient number of pieces. Furthermore, if we look at the sides of our figure, we see that for this first frame, the side is at quite an angle. But in the second one, the side is more vertical. Again, we can make this side as vertical as we would want by taking the circle and cutting it up into more and more pieces. In the end, we can get as close to a rectangle as we would want by cutting the circle into pieces a sufficient number of times. The idea of the limit can be done intuitively, but we can take opportunities, like here with the area of a circle, to lay the groundwork for a more formal understanding of these important mathematical concepts. The area of a circle inset can help students with discovering or rediscovering the area of a circle, but can also prepare them for more advanced concepts later on by choosing what we want to emphasize as we use this material.